Picture this. You gaze into a mirror only. It's not made of glass, and it doesn't just show your reflection. It's a portal through time itself, revealing not your own face, but the first fragile moments of existence. You are looking at the universe's earliest breath when the cosmos was still gathering itself into being. That, in essence, is the mission of the James Webb Space Telescope, to peer so deeply into the darkness that we might see the dawn. But when its golden mirrors opened their eyes to the farthest reaches, they didn't find the simple beginnings we expected. They found something impossible, something that shouldn't exist at all. For decades, scientists believed they had the story of the universe's origin more or less mapped out. First came the Big Bang, followed by a long, lightless age. Then, gradually, gravity drew matter together. Stars were born. Galaxies assembled themselves. Over billions of years, complexity emerged from simplicity. And so the further back we looked, the more primitive things should be clouds of gas, scattered particles, raw chaos. But when Webb studied a quiet, unremarkable patch of the sky, a place where astronomers expected almost nothing, it saw a galaxy. Not a newborn cluster struggling to coalesce, but a fully formed, graceful spiral, complete with arms winding around a dense, luminous heart. At its center was a black hole of staggering mass. This was not a faint smear of ancient light. It was a work of cosmic architecture, and it was not alone. One after another, Webb uncovered more of these galactic veterans hiding in the young universe mature, stable, chemically enriched systems that had no right to be there. It was as though the cosmic clock had skipped ahead by billions of years. The laws of astrophysics, as we knew them, were simply not compatible with what the telescope was seeing. The deeper scientists looked, the stranger it became. These galaxies contained heavy elements, carbon, oxygen, even iron, that should have taken generations of stars to create. In our models, the first stars burned only hydrogen and helium. When they died, their explosion seeded space with the heavier building blocks. That cycle was supposed to take eons. Yet here were galaxies less than 400 million years old already, hosting multiple generations of stars. The early universe wasn't drifting slowly into complexity. It was racing. And then came the most staggering revelation of all. At the core of one of these ancient galaxies lay a supermassive black hole, weighing more than 1 billion suns. By every calculation, such a monster should have taken billions of years to grow. Yet there it was, fully formed, almost at the universe's birth. It hadn't crawled through ages of slow feeding. It had appeared as if fully grown. Faced with the unthinkable, astronomers began to consider radical possibilities. Could black holes have formed directly from the collapse of dense regions in the early cosmos? Could dark matter have sculpted galaxies faster than we imagined? Could time itself have flowed differently in those first moments? And just as these questions took root, the anomalies deepened. Webb's data revealed that these early galaxies were not randomly scattered. Their shapes and positions echoed a precise mathematical order patterns eerily reminiscent of the golden spiral, repeated across billions of light years. What we assumed was chaos now looked like geometry, as though the universe had been etched with a blueprint from the very beginning. Then, in a silent, ancient void where nothing was expected, Webb detected the chemical fingerprints of complex organic molecules, ingredients for amino acids, the foundations of life itself. They were not bound to planets or stars. They drifted freely, surviving for nearly the entire history of the cosmos. If these molecules had been present from the start, then life might not be a rare accident. It might be a built-in feature of reality. But the most haunting image came from a place astronomers now call the flower, 6 galaxies arranged in perfect symmetry around a central object, spaced and moving in flawless harmony. No natural explanation has yet been found. Some call it a coincidence. Others whispered it might be something else entirely, something place to be discovered only when we were capable of seeing it. And finally, a theory emerged that few dared speak aloud. What if, in looking so deeply, we had changed what we saw? Quantum physics tells us that the act of observation can alter an outcome. Could that principle apply to the universe itself? Could the very act of peering into its earliest light have stirred it in some way, made it respond? A few researchers now claim that some Webb images seem to shift subtly over time, as though reality itself were aware of being watched. Perhaps the telescope's discoveries are not just relics of a distant past, but messages light woven with intent, patterns that remember. Perhaps we did not merely observe the universe. Perhaps, for the first time, it observed us. And that leaves us with one last question. We know what the Webb telescope saw, but what or who saw Webb?